Hi everyone, I'm Aries Keck here at NASA Goddard Space Flight Center, and we're doing a Hangout Live today with two of our scientists who are pretty much at other ends of the Earth, and we've got a school that's here in Maryland where Goddard is as well. They're at the Naval Academy Primary School in Maryland. We're going to be talking a lot today about IceBridge. Hi school, going to you guys shortly, and we're going to show some videos as well. First, I'm going to introduce Nathan Kurtz. He's the project scientist for Operation IceBridge, and he is reaching us from what looks like an office or maybe a hotel out there at Buenos Aires, Chile. Nathan, can you say hi?
Hi.
All right, Nathan, so tell us what you're doing there in Chile.
So we're here in Chile with a plane. It's called the G5. We've loaded up with instruments. We have a laser on board, a camera, and we're flying around Antarctica, around the oceans around Antarctica, and we're measuring the ice, how thick it is, where we're losing ice, things like that.
Fantastic. And now if you're watching this, as you can imagine, having somebody in Chile and another person in Greenland, we're going to be a little patient with our audio or any kind of technical issues. It's going as well as it's going so far. Let me see if I can bring John Woods, who's in Thule, Greenland, in. He's the project manager for Operation IceBridge, and I think he's in the airplane hangar itself. Hello, John.
Hi, hello everyone. Yes, my name is John Woods, and I'm currently the project manager for NASA Operation IceBridge. And unfortunately, we're not in our hangar, so our plane is actually in the hangar next door. But I do have two of our pilots here available to answer any questions if anyone has any pilot-specific questions.
All right, fantastic. Well, hey, since we've got the pilots there, let's go talk to them right now. John, do you mind taking it away?
All right, stand by 1 second. I'm going to unplug my headphone here, see if I can have each of them introduce themselves.
Hi, I'm Timo Thorson, and I'm Greg Slover.
Was that audio okay?
It's working fairly well. So let's have, pilots, before we lose you, let me have you guys describe what it's like to go out on a flight.
Okay. You mind putting on my headphones? I want to describe what it's like to go on a flight. Stand by 1 second.
Hi, can you hear me?
Yeah.
Well, what it's like is that we get up really early and we find out what the scientists want to fly based on the weather that we have. And if the weather is clear, and so Greenland is a really big island, and so we look for really clear areas, so the instrument that we have, which is a laser and a camera, can see all the way to the ice. And based on the weather, we get together and about a couple hours before we fly, and we will fly for about 4 hours, and then come back here and land, and the scientists take a look at the data. And we do that just about every morning that the field's open.
And now, pilots, what are the planes like that you're flying out there?
I always put a picture of it, but you can Google an image of an HU-25 Guardian, and there's some pictures of our plane scheme on it from NASA. And we got our twin-engine jet from the Coast Guard. We currently have one that's flying right now, and another one's about to start flying again, and it seats right now the two pilots, and we carry 3 researchers with us, and that's how we float up from Virginia as well.
Excellent. And so now you guys are up there in Greenland. Nathan, you're down at the other end of the Earth. Are you doing similar flights from down there in Buenos Aires, Chile?
Yes, we are. We also have it's not a large plane, but it's decent size, and we have our 2 pilots that fly on board. We have a laser operator, a camera operator, and then the techs on board. And they're longer flights out to Antarctica. It's to the southern or the northern tip of the Antarctic Peninsula. It takes about 2 hours to get down there. So just our transit to and from Antarctica is pretty long. So our flights are about 10 or 10.5 hours every day. And some of our targets are actually quite far something like the Getz as GETZ ice shelf is actually quite far away, so it takes almost 4 hours to get there. We also have a mission that we haven't flown yet to the South Pole, and that's pretty much just flying. We kind of fly a circle around the South Pole, go to the South Pole, and then go up. So it's always dependent on weather. We don't ever know where we're going to fly until that morning, and then we kind of make a call to decide where we're going to fly.
Fantastic. Thanks so much. That's Nathan Kurtz, of course. He is down at Buenos Aires, Chile. And now we have a school who's joining us. Hello, school. If you guys want to unmute yourselves and see, do you have any questions for the scientists that are there? The school that's joining us is the Naval Academy Primary School, which is located in Maryland. Hi, guys.
Hello.
All right. So what question?
More of us. There's not more.
Hi. Okay. So what questions do you have for the pilots? Let's have one of you guys ask a question of the pilot.
Anyone? How long did it take for them to get there?
Okay. Did you guys hear that? So the question the school just asked, and I put them on mute just because there's a bunch of them there, but the question they just asked was, how long did it take you to get there? Let's go to the gentleman in Greenland first. How long did it take you to physically get up to Greenland to even start doing your job? And yeah, I think your microphone's muted, so you want to unmute your microphone. Let's see. Can we hear you? If you're in Greenland, try unmuting your microphone there. There you are.
There we go. We just unmuted. My name's Greg again, and
Greg, hi.
we have our airplane is out of Langley Research Center, Virginia. So we flew from Virginia up to Greenland. It took us 3 flights and about 7 flight hours. We stayed overnight in Goose Bay, Canada. The airplane can actually get there a little quicker, but because of the remote location of Greenland, we had to make sure to carry extra fuel reserve. So we left Goose Bay, Canada, and landed at Kangerlussuaq, Greenland, before coming up to Thule Air Base. That allowed us to carry the extra fuel reserves needed in order to come up here safely. And for the operational missions, we also carry extra fuel, which keeps the sorties down only to 4 hours maximum.
Excellent. And now, Nate, to you, how long did it take you to just physically get down to Chile to start even doing this job?
It took me about, I believe, 30 hours. I flew from Washington, D.C., down to Miami, down to Santiago. I was flying overnight, and then I waited in the Santiago airport. And flew down to the southern tip of Chile. So the plane that we took down here took off from Colorado, just outside of Denver. They flew. It took them 2 days to get down. They stopped in Arica, Chile. They picked up an observer from the Chilean military. On the way down, we actually flew over several different targets. We flew over Costa Rica and some volcanoes in Chile. So on the way down, we turned the laser on and turned the cameras, and we were actually taking measurements on the way down in several places. So about 2 days to get down here.
Excellent. Okay, so Naval Academy, let's go back to you guys. Do we have another question for our scientists there? And don't forget to unmute yourself first. And you do that by going to the very top of your screen.
What's the weather like down there? Down there in Greenland.
And up. Greenland's up. Chile's down.
All right, let's go to Nate first. Nate, tell us what the weather's like down there, and then we'll go up there. So, Nate, you're essentially down there in Chile.
Yes. So the weather in Chile, because it's the southern hemisphere, the seasons are opposite. So it's just coming out of winter and coming into spring. So it's a little bit chilly. It's maybe 40 degrees on average here. So But the big difference here, the winds are very, very strong. It's very common to get just, I don't even know how fast of winds, and I mean it's constantly blowing, and so this is actually a hazard for the plane itself, because if the winds get too strong, we actually have to move the plane away. So, but otherwise, it's pretty nice in Chile actually.
And now up there in Greenland, let's have you guys talk about the weather. I mean, from the parka, from the clothes you're wearing, the parka you're wearing, it looks like it's pretty cold.
It has been really cold. It actually started out at about minus 10 degrees Celsius earlier in the week, but we had really nice and clear skies. And unfortunately, we just had a blizzard last night where it was blowing snow and with about 50 to 60 knot winds. So we were all confined to our quarters last night. No one was allowed out. And we just came out of our lockdown earlier this morning. But it's still blowing snow out there. It's about 25 miles an hour, and unfortunately no one was able to fly today. So the weather's been pretty rough, but fortunately some of our science targets are away from the airbase. So as long as the plane can take off, there's other parts of Greenland that have decent weather that we can fly over.
That sounds pretty intense. So we have some video that I'm going to throw to a little bit to play, and I'm thinking that Nate and can talk about it a little bit. Sorry, and let's see if it's going to play. These are essentially what I believe are flyovers. Nathan, can you tell us a little bit about what we're seeing here?
Wait, I don't see the video yet.
Oh.
I see.
Let's see what I'm seeing
on Jefferson's screen there.
Should be at the top. Well, let's go back.
Okay.
Oh, you seeing it?
Oh, I see it now. Yeah.
Thank you, Nathan.
So this is a flyover of an ice sheet. See the crevasses. That's flying over a mixture of water and ice there, so probably along the edge of an ice sheet. So that rough area, those are crevasses in the ice. Sometimes they get very, very deep. That's what you want to avoid if you're walking on the plane. This is the plane that we're taking down south in Chile. It's called the G5. That looks like, and so this is the plane from Langley. This is the Falcon that they're taking in Greenland. So the two planes that we have on the mission right now. Let's see, that's our mission scientist. His name's John Sontag. He's up in Greenland as well. He decides things like checks the weather, makes sure everything's going smoothly, makes calls on the ground. So we have him up in Greenland, and I'm down here in Chile doing a similar job right now.
And now a question for you, Nathan. So why do two campaigns at the same time? Why not just focus on one at a time?
In the past, we had focused on one campaign at a time, putting on different instruments, more instruments on one plane. This year, we don't have the planes that can fit all the instruments that we have, so we decided to take planes that fly at high altitude and take more specific kinds of measurements. And so by doing that, we can actually take measurements at different times of the year. Usually, we had been taking measurements always in the spring, so it's now spring in the southern hemisphere. And we had always been going to the Greenland and the Arctic in March and April and May, which is also the springtime. When you take measurements at different times of the year, so now we're in the fall time in Greenland, it's just after the summertime. So in summer, everything's melting, obviously. Not all of Greenland starts to melt typically, but a large portion does. And so we don't always know what happens, how much snow is melting, how much snow is falling. So when we come back in the fall, after we've taken measurements in the spring, we can get a sense of, well, what happened over the summer, doing things like, we try to improve predictive models. So what's going to happen to Greenland many years from now? And to do that, we have to know, well, how good are our models and how good are we representing certain physical processes? So by going in the fall, it gives us more information basically to do that.
Okay, wonderful. Let's go back to the school for a second and see if you guys have another question for our scientists. Let's go back over here. You guys are probably the big bucks there. So let's hear again from the Naval Academy. And don't forget to unmute your microphones and give us another question.
What animals have they seen up in Greenland?
All right, now mute your microphone again, and that sounds like a question for John Woods up there in Greenland. Have you seen any animals? I know you're obviously focused on studying the ice, but what wildlife do you have to be aware of up there?
So actually, there's a pretty large family of Arctic foxes that live on the base. We pass them almost every day, and it's been really neat to watch them getting their winter coats filled in. So they started out almost black in color, and they're actually turning much more white. And it's just in good time since the snow has started to fall, and they're blending in with their environment much better now. And also one day when we weren't flying, I was able to get up off base a little bit and see some Arctic hares, which are really impressive, some of the largest bunnies I've ever seen. And they're quite funny looking. They stand up on their hind legs, and they run or hop pretty fast. So we saw a couple dozen Arctic hares as well when we were off base the other day.
And now back down to Nate. Are there similar types of animals that you have to be concerned about when you're doing the flights from Buenos Aires, Chile?
Not so much in Chile. In terms of flying, we do fly over penguin colonies. Now, this mission we don't have to worry about flying over the penguin colonies because we're high altitude, so we're far enough away not to bother them. In the past, we had flown low altitude, and so we actually had to have a map of where all known penguin colonies are, so we can maneuver around them because we don't want to interfere with anything. I think the plane actually, because it's so loud, it actually disrupts their environment, and so we do have to be aware of that. We do see wildlife from the air. We haven't seen any from the high altitude, but in the past, do see seals. There's some very large seals that we can see down on the ice from the air. Other than that, I mean, Antarctica itself, other than penguins, there's no large animals, and so just on the ice around it that we will see. Lots of seals. Also, I guess to bring it back up to Greenland, there are polar bears around Thule to be careful of. They don't always hang around there, but I have been around when last spring when we were there. There was actually, they had found a polar bear not too far off. I think it was about 15 miles off the base.
Great. Let's go back to the classroom again and get another question from the Naval Academy kids. Hi, guys. So don't forget to unmute your microphone and give us a question.
Margaret, you can ask.
Wait, is it hard work?
Is it hard work?
Say it a little louder. Is it hard work?
That's a good question. All right, is it hard work? Let's go up to John up there in Greenland first. John Woods, the project manager. So, is it hard work? You were talking about a blizzard yesterday. That did not sound like easy work to me.
Yeah, it's definitely a hard work environment, and it's really long days. You have to wake up really early and check the weather. So even if the weather doesn't look that promising, we still have to get up and go through the normal routine to see if we can possibly fly. And then if we do fly, for instance, on the last day before the storm hit, we were actually able to fly 2 missions. So the pilots were out for 4 hours, came back, got a quick bite to eat, refueled the airplane, and then flew again for another 4 hours. So they were up in the air for 8 hours, and then not to mention the crew on the ground to support the plane. They had to be here, before the flight and then again after the flight. So definitely hard work in a challenging environment, but it's really rewarding and fun. It's a really neat experience to be up there in Greenland.
And now, Nate, on to you a little bit. If it was hard work, obviously it is, but I mean, how do you deal with the extensive amounts of darkness and sunlight that you have to deal with for these kinds of scientific work?
It's actually, at least where we are, it's the latitude's not far enough away, so we don't have to deal with too much excessive light and dark. In Greenland, it's much different. So, but otherwise, I think the most challenging thing, I guess, in terms of is it hard work, is a lot of what John said in terms of we have to get up very early to check weather. When we do fly, it's 10.5-hour flights, and then we come back and we always want to check everything that we had done. So we do that in the night or the next day, and always try to plan for the next day. So days are long, but again, it's definitely very rewarding and fun.
Okay, so let's go back to the school again. School, hi. All right, so let's get another question from you guys about the science that they're doing up there, if you have it. So don't forget to unmute your microphones. And to unmute, you go to the top of your screen. All right, go ahead, school.
Hey, Kevin. Well, do you like eat different foods up in Greenland?
All right.
Down in Chile.
The question.
And down in Chile?
The question is, and let me put you guys back on mute. And see, John, I think your mic's open. Mike, so they were talking about, I'm sorry, your microphone's open. So John Woods, you were talking about what kinds of food you eat up there. I can imagine it can be quite comforting to come in and have something warm after these blizzard conditions.
Yeah, so we actually eat pretty well up here. Greenland is actually a Danish-owned island, so there's a lot of Danish food, so authentic Danish foods, a lot of fish, a lot of different meats that you might not normally experience in the United States. But they also do have a lot of American offerings. But usually at each meal, I like to try at least one authentic Danish food. But they definitely feed us pretty well. Although, again, last night, since we had the blizzard, no one was allowed out, so we had to make our own dinner in our dorm rooms. And they actually handed out meals ready to eat, which are like the Army boxed meals for breakfast this morning until the base opened back up.
And now, so what's a traditional Danish meal?
So lots of different fish, some raw fish, which I've tried but not enjoyed too much. Some different types of sausages. They have hot dogs here that they call hot dogs that do not look like our hot dogs. But again, everything seems to be worth a try at least once.
And now, Nate, you're down in a completely different part of the world. And Nathan, is it different down there with what you're eating, or is it a similar fish-based food?
It's quite a bit different. I think Chile has its own kind of cuisine, and most of the restaurants here that we eat are Chilean. But since we're in southern Chile, I think the biggest difference is that there's just not many fruits and vegetables, except for canned food. So there's just very little fresh fruits and vegetables. So a lot of the food is meat, cheese. They do like their sweets here, so they have excellent selection of cakes and things like that. But other than that, it is pretty good food. But again, not many vegetables and fruits, so not so much healthy eating, I would say.
Okay, so we're going to talk a little bit about the science of this mission a little bit. An ice bridge is not only studying land ice, it's also studying ice sheets and glaciers and sea ice. So Nathan, we're going to play some of this video. Can you explain a little bit about what we're seeing as this plays?
So what you can see, the border around Antarctica, it's kind of shifting. That's the edge of the sea ice. So as the season changes, the sea ice grows and shrinks based on winds and how cold it is. So this video is, you can see mountains in the background, but then the water itself, the ocean surface, freezes and it gets quite thick at times. But what we're seeing here is sort of a mixture of the darker ice isn't quite as thick, doesn't have any snow on it, but then you see it mixed in with ice that does have snow on it, so it's probably a bit thicker. And it moves around quite a bit, so you don't just see a big white sheet of ice. It's more typical in the Arctic. In the Antarctic, you see a lot more variety just because of the ice is thinner, it moves around more. It's more expansive. So this is very new ice. Probably the ice had opened up a bit. It's just so cold and it freezes over. This looks like near the edge of the Antarctic. So in the background you can see the edge of the ice sheet. And what happens is there's very strong winds. They just blow. They push the ice away from the continent, and it keeps the ocean ice free. But then it starts to form new ice. It's just so cold down there. Here there looks like icebergs mixed in with the ice. So the icebergs calve off the land and throwing out the continent, blowing the ice away, but it's in the process kind of creating new ice. So this is one of our instruments taking pictures on board the aircraft. So here's a field of icebergs. So this is near the continent, just calving off lots of big icebergs that you can see. Means these things are just huge. They're massive, easy to spot from the air. This, again, icebergs mixed in with the ice. Here's some more sea ice. A bit hard to tell what's going on in this sea ice, but so that again looks like all Antarctic sea ice. And one easy way to tell is it's I guess the sheer variety. So from the snow-covered to the non-snow-covered, and again the huge icebergs all over. Antarctica just calves off so many icebergs. So it's pretty much what we're seeing on the flight. So.
Fantastic. Thanks so much, Nathan Kurtz. Hey, let's go back up to John Woods real quick up there. I'm wondering, we hear a lot about how things are melting at our polar regions, and I know that's one of the parts of this mission is to keep track of this ice. Have you been able to see differences as you go up from year to year?
Yeah, definitely. That's exactly what we're trying to do is by measuring the melt summer or fall season right now compared to what we saw in the previous March season. I do believe that every year that they come up here, they do see a little bit less ice each time. So there definitely does seem to be a decline in the ice, and that's exactly what these measures for, so we can track that decline in ice. And I know this is my first time in the fall time, so I have nothing to really compare to, but I know when I was up here springs ago, and talking to the people that have lived up here for 7, 8, 9+ years, they have mentioned that they have definitely seen a decline and a change in the amount of snow and cold weather they're experiencing.
And now, John, up there in Thule, Greenland, I know the flights are higher this year in altitude. We're going to look at a little bit of video of that, but while we're doing that, can you explain what's the importance of flying at different altitudes above the ice?
Yeah, so the plane that we're on this year, it's as the pilots explained, it's an old Coast Guard plane, and it's really optimized to fly at a higher altitude, so you can get a much longer range, so we can fly much longer missions when it's up at altitude. And the instrument that we're using, that we've been using in the past at lower altitudes, they've modified it to be able to those higher altitudes. So this is the first time that they've flown it this high over Greenland. So they're kind of working out the bugs, but they've been collecting some great data, and they're really looking forward to using it again this way in the future if we can't get back down at lower altitudes.
Excellent. Okay, let's go back to that Naval Academy and have you guys do one more question. I think we have time for probably 2 more questions. Let's do one now. So don't forget to unmute. There you go.
What is the time? What is the time difference?
All right, so the question is, what is the time difference? Go to Nathan Kurtz first down there in Chile.
The time difference here, it's only 1 hour time difference from the eastern U.S., so the eastern time zone. So not much different. It's 1 hour ahead.
And up there in Greenland?
And so we're an hour ahead, but even more interesting, I think, is that we're losing about 15 minutes of daylight a day. So since we've been up here, the sun has risen an hour later each morning. So when we used to go to breakfast and to the early morning weather brief the first day we got here, it was sunny out, and now it's dark. And then when we come in at night, again, it's getting darker a lot sooner. And you definitely notice the difference from day to day, how they're losing up here until they'll actually go into complete darkness here in another couple of weeks.
And now the main question, you guys, we both introduced you as a either project manager or a scientist for Operation Ice Bridge. The biggest question we get is exactly what is this ice bridge? What are you trying to bridge between the two? Nathan Kurtz, let me have you answer that one.
So the concept of the bridge came out. NASA had a satellite called ISAT, which was launched in 2003. It was a laser taking measurements of the surface. ISAT failed in 2009, and the next version of ISAT is actually not set to launch for about another 2 years. So in the meantime, NASA decided to have a plane take similar kinds of measurements. And so that's sort of the bridge that we're trying to do is bridge these two satellites, so make sure we're not missing something. But in the meantime, you can actually put a lot more instruments on a plane than you can on a satellite. So we typically fly a set of lasers, radar, very different kinds of radars. For some radars measure how deep the snow is. They don't go down very far under the ground. Other radars that we have actually go all the way to the bottom of the ice sheet, so can go down more than a mile into the ice just to see how thick it is, where the rock is. So other things that are on, we sometimes have an instrument that measures the gravity field, and based on very small changes in the gravity, you can tell sort of what kind of material is under the ice. So this video is showing the concept of the radar. So the plane's flying over an ice shelf, in this case, taking laser measurements of the top, a radar that's going down underneath. And so when we combine the two, the radar going underneath, we get a sense of, well, are we losing ice? If we're losing ice, or are we losing snow? Are we gaining ice? Are we gaining snow? So really, what's happening to change the ice sheets? And so putting as much as we can onto a plane, taking all these different measurements, tell us what's happening to the ice. And so bridging this gap between the ISAT satellites helps us do that.
Fantastic. All right, so one last question from the Naval Academy kids who've been joining us. Let me go over to you guys. So this is one last question from you guys. Make it a good one. Oh, and don't forget to turn your microphone back on. You have to do it up at the top of your screen.
Abby.
There you go.
Go, Abby, just.
Okay. We can hear you now.
Abby,
Hi.
do they know?
Affecting you?
They know where. I say, do you know where her hurricane?
So the question is.
Do you know we're having a hurricane right here?
Okay, there you go. So let's throw it up to John first. Is the hurricane that we're having here on the East Coast of the United States affecting you guys?
Do you want to hear your question answered?
Not affecting us directly, no, but a lot of the people that are on the crew here are from the Virginia area, so they're pretty nervous. I know my family's back home there in Annapolis, so we're thinking about everyone with the hurricane coming up the East Coast, and we've been watching the weather closely there as we have up here.
Excellent. And now on to you, Nate. Are you having the same thing with just the people here you are at a rather extreme part of the world, but here we're having rather extreme weather right off the East Coast of the U.S.
Yeah, it's pretty much what John said. My family is back in Maryland. Some of the crews has family in the path of the hurricane, so that's pretty much the extent of it. Otherwise, no other direct impact on the mission. There can be other factors like that do have an impact. There was an earthquake not too long ago just off of Chile, which ended up delaying some of our shipments a little bit. A volcano went off on one of our planned flight tracks. We had to divert around it a little bit. So there are always natural disasters that happen. We just got to prepare for it.
Okay, so John, just as we're going to wrap up here, let's go back up to you to Greenland. If you can tell us just a little bit more about maybe what's going to be happening in the next few days or what you're going to do with the data when you get back home.
Yeah, so we're actually up here in Thule, Greenland until Wednesday, and then actually we're taking our NASA jet will go down about 2 hours south of here to a smaller town called Kingarusuaq, Greenland. 2 weeks out of there onto science targets down in the southern part of the island. So we're hoping to get 2 more science flights in on Monday and Tuesday. Unfortunately, the airport is closed here on Saturday and Sunday. We're hoping actually to get 2 more flying days in, and possibly even two research flights each of those days before we go down for another 2 weeks in southern Greenland.
Fantastic. And now Nathan Kurtz down there in Chile. Tell us a little bit about the final bit of what you're going to be working on.
So we have about another month that we'll be down here. Right now we're actually flying because weather is just too bad over all of Antarctica. There's just clouds everywhere. Or as we found out, it's actually too cold for the plane to fly in some places. It's 80 below zero. So then the plane does not fly. Gets too cold for that. So it's looking like weather's going to be better tomorrow, so probably fly around the Antarctic Peninsula, and that's pretty much what we'll keep doing. As long as nothing's wrong with the plane, instruments are working, and weather's good, we'll just keep flying back and forth.
Fantastic. All right, so let's go back to the Naval School. Just have you guys say goodbye. Thanks so much for joining us. You guys want to say? Bye. And that got a little loud here in Greenbelt, Maryland. Thanks for joining us, everyone. Thanks, Sean. Thank you so much, Nathan. Right.
Thank you.
Thank you.
Thank you. Thank you. Thank you, everybody, for joining us. So this has been a live, obviously, Google Plus Hangout. I'm Aries Keck here at Greenbelt, Maryland for Goddard Space Flight Center. And I really want to thank both Nathan Kurtz and John Woods from the Operation Icebridge team. Thank you guys so much for joining us from both ends of the Earth, and we hope you have safe travels back here, back home. Thanks again.
Thank you.
Thank you.